without using technology, sketch the graph of y equals sine 2x for x between 0 and 2 pi. Right, I'm going to give you two ways to think about this. We'll start with the sort of thinking of sine x as the parent function as the f of x. So say f of x equals sine x, or sine 2x, x is f of 2x. What I mean by that is you're changing the input before you're applying the function to it. So it's like the thing that you're putting into the function. I mean, the initial function is to take the sine of an input x, right? What we're doing here, we're doubling x and then we're taking the sine of it. So you're adjusting the input. Anything that happens inside the bracket or to the input, it's a horizontal transformation. If it's a multiplier, it's a stretch. So this would be a stretch, as in from f of x to f of 2x. It's a stretch. It's a horizontal stretch, but I'm going to write it in terms of an invariant line, because I think although it's a few more words to write, I do think it helps you do the stretch better. So the invariant line will be the y-axis. Y-axis invariant, as in the y-axis is the invariant line. Scale factor is 1 over 2, right? So when you've got a multiplier inside the bracket, or you're multiplying the input, then you always take the reciprocal. Scale factor is 1 over 2. So that means if we use our y-axis as the invariant line, all of those perpendicular distances for key points, well, for every point, but we'll do it by looking at key points, all of those distances will be halved in the perpendicular direction, as in along a horizontal line back to the y-axis. So that's one way to look at it. The other one is by thinking about the period. Now, if we have sine bx, okay, so in this case b is 2. Basically, the period for this graph is 2 pi over b. Okay, so the period for normal sine and cos is 2 pi. It takes 2 pi, 360 degrees, or 2 pi radians to do one full cycle. Right, so if you do something like this, as in you change the input before you do it, the period will adjust to 2 pi over b. So in this case, period is going to be 2 pi over 2, or 2 pi over 2 is just pi. So what that means is it will take pi radians, or 180 degrees, to do one full cycle. So that's another way you could think about it. There is actually a third way, is that I always think, well, sine 2x is going to do 2 full cycles in the time that sine x would do 1 cycle in. So it's going to do in 360 degrees, or 2 pi radians, it's going to do 2 complete revolutions, or two complete waveforms of sine. So 3 ways to think about it, and this should all get you to the same place. So if I just draw sine x, remember, sine x goes from 0 to pi, pi by 2, 3 pi by 2, up to 1, down to minus 1. This is sine x, and this is x. And remember, it starts at 0, up to 1, down to 0, just missed, down to minus 1, back up to 0, something like that. Sine x. Sine 2x, right, I mean, it's got a period of pi, so it's going to do all of this one full wave in pi radians, so it's going to go one full cycle. It's going to get from here to here with one complete turn. If you think about it in terms of the invariant line, if we pick key points, remember we've got a scale factor of 1/2, so this is the invariant line, the y-axis. So say we take this point here, well, that is going to be half as far away along the horizontal line back as in the perpendicular line back to the axis. That point is going to be here. We take this point here, well, that is going to be at pi by 2 instead. if we take this point over here that was at 3 pi by 2, well, that's going to be half of that, which is going to be between pi by 2 and pi, just here. Everything gets halved, right? If we take the point at 2 pi, well, that's going to go up to pi. So you can see, if I just draw that, you're going to get one cycle like that. So it's a bit wonky, but hopefully you get the idea. It's going to do this, and then it's going to do it again. So that's where the invariant line gets a bit tricky. Because the problem with sine and cos or tan periodic functions is you can't just do the stretch and then forget about the rest, because they do keep going. So then you need to recognize, well, it's going to do the same again. So it's going to go to here, and it's going to go up to here, and down to there, and it's going to do another turn. Something like that, which isn't fantastic, and it is a bit wobbly, but that is the function. This is y equals sin 2x, and that's that line, and the initial was y equals sin x. Now, I'll just take you back to what I was saying about when you get sin 2x, it just means you get two cycles in 2 pi radians. It might be easier to draw it like that. Sometimes it's easier to draw the graph and then the axis. I find personally, you can see that my lines are really not the smoothest. But if I know it's going to do 2 cycles in 360 degrees in 2 pi radians, I can just start from here and I can just do one sine wave, another sine wave, and then I can just draw the axes. So I know that that was 2 pi, so this must be pi. And just fill everything in. It must be 0, this must be pi by 2, and so on. Just fill everything in like that, get your axes, and it's done. So it's the same graph. Obviously I've had to, if you have to draw them on the same graph, you've been asked to draw sin x and sin 2x on the same graph, then fair enough. But if you just need to sketch one, then I think personally I find this easier, but everybody's different, it does depend. And hopefully you're a lot better at drawing than I am.